The diagram figure 3 shows the cross-section view of a heavy uniform plane of weight 400 Newton and length 2 meter in at A and supported by force F. Calculate the magnitude of the force F and the magnitude of the resultant force excited by the hint on the plane at A. So first step, we know that the length of this plane is 2 meter. So mean that we can calculate angle. So we can calculate angle theta here. So we use sine theta equals to 1.2 divided by 2 meter. So you get theta equals to, this is sine 1.2 divided 2 here. So you get 37 degree. Around 37 degrees. So here is 37 degree. So mean that here is 53 degree. So our plane here is uniform. So it means that weight for plane here at the center. So direction weight straight downward. So now the system is balanced. So here we have two forces, weight and force. To check all the forces here, yes, so we use closed polygon. So make sure your polygon close. So now we check our forces here. So here is weight. Then continue to force F. Apply force F here. So we have only two forces. So it means that the polygon is not closed. So we need to close to make sure the polygon is closed. So force F is like this. Say we label is force S. So where is force F? So it means that force S must be on this plane. Okay, so maybe here at point A here. So direction force F is like this. So here is force S. So now the system is balanced. So it means that net torque equals to 0. Net torque equals to 0. So it means that torque clockwise equals to torque anti-clockwise. Torque 0 and also force, summation force also equals to 0. So it means that F at 0. F at 0 means that force at right side equals to right hand side equals to force left hand side. And y axis also equals to 0. It means that force upward equals to force downward. In that torque at point A equals to 0 because R here equals to 0. We know that torque is a vector equals to R cross F. So magnitude torque equals to RF sine theta. So theta is angle between R and F. So for case here is axis rotation at point A here. So R for vector S is 0. So mean the torque at point A here for S equals to 0. For weight here, another force weight. So R here is R from axis rotation to apply force. Weight here is R. Let's say here is R1. So R1 here is midpoint of plane here. So it means that R1 here equals to 1 meter. And direction R1 from axis rotation to apply force. So it means that it rotates clockwise. And angle theta, okay, we can, so angle between R and force weight here equals to 53 degree here. Okay, and now for force F here, so from excitation to apply force S here is R2. Direction R2 from excitation to apply force F. So R2 here equals to 2 meter. So angle between R2 and F, here is action line for apply force F. So between force F and R2 here is 37 degree. Okay, then we rotate here from axis rotation R here and to apply force F. So it means that it rotates anti-clockwise. The system rotates anti-clockwise. So torque clockwise equals to torque anti-clockwise. So torque clockwise here is for weight. So weight R1, weight sine theta 1 equals to torque anti-clockwise R2 apply force F sine theta 2. So R1 equals to 1 meter and weight 400 Newton. Sine angle here is 53 degree. 53 degree equals to R2 is 2 meter times F sine angle here is 37 degree. So you can determine force F. So we use calculator. So 400 times sine 53 and divide by 2 sine 37. So you get answer 265.41 Newton. So for A, answer force F equals to 265.41 Newton. And next for B, to determine force at point A, so we use X and Y component. So refer to the diagram here. X-axis, we have force to the right here is apply force F. So it means that force to the left here is SX. Here is XX. Direction XX to the left. And SY, direction SY upward here. So you get closed polygon here. Here is SY. So F right here is apply force F. And F left equals to SX. So you get SX equals to F equals to 265.41 Newton. And for y-axis, F up equals to SY. And F downward equals to weight. So meaning that weight now equals to 400 Newton. So determine S. So S equals to third Sx squared plus Sy squared. So substitute the value Sx 265.41 squared plus Sy 400 Newton squared. So you can determine force S. So use calculator. 265.41 squared plus 400 squared. So you get 418 Newton. And for direction, we use tangent. Tangent theta equals to y-axis per x-axis. So y-axis equals to 400 and x-axis equals to 265.41. So you get theta equals to 400 divided by 265.41. Shift tangent 56 degree. 6.43 degree. So theta here, okay, Sx here to the left and Sy upward. Okay, so here is Sx and here is Sy. So angle theta here is above negative x-axis. So this one is magnitude. And this one is direction.